Hi, today we will do some conversions of units. So let us see in this diagram I have made using all the multiples of unit and all the sum multiples. The bigger one units are called multiples. These are your multiples. And the smaller units of the SI unit meter. So smaller one you can take some multiples. These are your, let me delete. These are your sub multiples of units. Now you can notice that each is increasing by a product of 10, means increasing by 1 power of 10. Here you have in meter 10 raised to power 0. Let me take color. Here you have 10 power 0. Then 10 power 1. Power is increased by 1. Then 10 power 2 increased by, again you can see that the power is increased by 1. Here also power is increased by 1. Up to this point power is increased by 1, and now further if you move, power is increased by 3 for megameter. Now if you further move again, power is again increased by 3. Power of 10 is again increased by 3. In terameter also, in petameter also, power of 10 is increased by 3, and finally in hexameter. So very simply you can convert. Suppose you have to convert. And one more thing, you know that 200 centimeter is equal to 2 meter only. Bigger the unit, smaller is the number. Bigger unit, smaller number. Okay, so suppose you have to convert nanometer, suppose 29 nanometer, and you have to convert into terameter up to this value. So you will go this way. 29 will be the obvious thing. Okay, let me delete this line. You have to go up to this height. For converting it, convert this into terameter. So how will you do from nanometer from here? Power is changed by 3. 3, again power is changed by 3. 3, 3, 6, and now onwards power is changing by 1. So 3 plus 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, 20, 21. Okay, so 10 power 21 and into 29. Do 29 here. Now, terameter is a big unit, so the number should be small. So you will write here, you will give here minus sign. Now suppose you have to convert 24 millimeter. Okay, this is one case. Let me change the color. Okay, now let me take this deeper one. So if you try to convert 26, here this is your 26 millimeter into megameter. Okay, megameter. Then what will you do? Here power of 10 is increased by 1, changed by 1, 2, 3, 4, 5, 6, and now power is changed by 3, 6, 7, 8, 9. So 26 into 10 power 9, and you will see that it is changed from smaller unit to bigger unit. When unit is big, the number should be small, so put here a minus sign. This is how you will be doing. Now next question, let me take some other color. Okay, this one. Okay, so now suppose you are to change some gigameter, means 21 gigameter into micrometer. Okay, let me change the color. It is matching exactly. Okay, this green one. You have to change from some gigameter, 17 gigameter into micrometer. So you can see the power, how power of 10 is changing from 9 to 6, 3, and then again 3, 3, 3, 6, and then one time the power is changing, 6, 7, 8, 9, 10, 11, 12, and then it is changed by 3 power 12, 13, 14, 15. So 17, just me do it again. So 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay, 10 power 15. And here unit is reduced. You can see unit is small. It is smaller than gigameter. So power will be plus. When unit small, number will be large. So power will be plus. This is how you will be changing unit from submultiples into multiples, and from multiples into submultiples. This is how you will be doing. So another way. Okay, so suppose you have to change 29 terameter into micrometer. Okay, let me delete this, into micrometer. You are knowing N1, you are knowing U1, you are knowing U2, but you are not knowing N2, and this N2 you have to find. Therefore N2 is equal to N1 U1 upon U2, and this is equal to 29 terameter upon micrometer. This is one thing. Now next thing, you need to recollect, you need to memorize the values of these prefixes. Do remember the values of prefixes. Means micro means 10 power minus 6. Do remember this. Tera means 10 power 12. So in this way you will be remembering values of all the prefixes, and you will put value of all these prefixes. Therefore N2 is equal to 29 into tera means 10 power 12 into meter, upon micro means 10 power minus 6 into meter. So meter cancel, and this becomes equal to 29 into 10 power 12 plus 6, because these are the exponents on same basis, so and they are divided, so power will be subtracted. Let me do in one more step. It is subtracted, power is subtracted. Therefore, N2 comes equal to 29 into 10 power minus plus, so you have 18. Therefore, N2U2 is equal to the value in second unit, another unit, is equal to 29. Let me put the value of N2, 29 into 10 power 18, and U2 is micrometer. So this way you can be doing all these things. Okay. So next topic, to find units of derived physical quantities in terms of base units. Okay, we have 7 basic physical quantities, and related to that we have 7 base units. So for length we have meter, for mass kg, for time second, current electricity ampere, luminous intensity candela, amount of substance we have basic unit mole, and temperature, for temperature we have basic unit Kelvin. And using these 7 basic units, we will be writing units of all the several hundreds of derived physical quantities. We have hundreds of derived physical quantities. So let us start with one example. To find unit of potential. Now potential is work done per unit charge. So it is equal to work upon charge, and work is similar to, work is equal to force into displacement upon charge. Now for force we have unit, kg meter per second square. For distance we have unit meter, and for charge we have unit, though we have unit coulomb, but coulomb is not a basic physical quantity, and it is not having a base unit. Coulomb is not a base unit. So we will find the base unit related to charge. Since current is equal to charge per unit time, therefore charge has unit in terms of base physical base units. So for I it is ampere, and for time it is second. Now you can put the value of unit of charge over here, ampere second. Therefore potential has unit kg meter square per second cube into ampere. And you can also write in a slightly differentiation. So you may write kg meter power plus 2, second power minus 3, ampere power minus 1. So this is the unit of potential. Unit of potential in terms of base units. Now next thing, unit of field, electric field. Unit of electric field. Since you know from your class 10 that electric field is force per unit charge. Therefore, electric field can be written as force divided by charge. So, SI unit, or better you should write unit of the derived physical quantity E in terms of base physical quantities is, for force you will be writing kg meter per second square, and for charge from here you can write for charge what we had written. So here the unit of charge, ampere second. You can see ampere second. So let me put here here you will be writing ampere and second. Therefore, it is equal to kg meter upon second q into ampere. And there you can also write in a slightly different manner. So put here power of m as plus 1, power of s as minus 3, and power of ampere as minus 1. In the same way, you can also write SI unit of, not SI. This is SI unit also. Yes, this is SI unit also, because all the units are in SI system. Okay, so a unit of resistance. We know that V is equal to IR, Ohm's law. Now put the unit of V, and we have obtained already kg meter square. Okay, it is here, you can see potential kg meter square second power minus 3 kg. Okay, kg meter square second power minus 3 ampere power minus 1. Okay, kg meter square. Okay, now unit of current is ampere and then R. Therefore unit of R in terms of base units is equal to kg meter power 2 second power minus 3 ampere power minus 1 divided by ampere, and this is equal to kg meter square second power minus 3 and ampere power minus 1 into minus 1. So this becomes equal to kg meter square second power minus 3 ampere power minus 2. So I